Okay, hello everyone. So this is Robert, and I will be telling you about the serverless one-stop shop we created for Qdance. I hope everyone can hear me. So I will get started, and hopefully I'll have an exciting session for you. Just up front, just so you know, this session does not cover anything Drupal related. So if you want to visit something Drupal related, then this is not your session, but I promise you I've got some really cool stuff to show. So thanks for joining. I'll give myself a short introduction. I'm Robert. I'm a technical director at MediaMonks, and I have a background in backend development, mostly in PHP and Node.js. And I've been with MediaMonks for over 15 years already. And we are a digital-first creative and production partner for many big clients. And we've been awarded on many occasions by different companies. And this is Qdance. I'm not sure if anyone knows Qdance. They are like the organizers of like huge festivals all over the world. And they are part of the ID&T group, and Qdance has its own events. Well known is Climax and DevCon, which are events that have most visitors from not from the Netherlands but from the rest of the world. So that's pretty cool. And also they have their own hosted events at Tomorrowland and Mysteryland, which are also two giant dance events. Also, Qdance fans are very loyal fans, and that means that they are always very excited to support their brand and wear the merchandise and go to all the events that are organized. And that is also the reason that Qdance came to us with the idea of something that we eventually called the one-stop shop. And this shop basically allows party people to get whatever they want in a single purchase. Because before the one-stop shop, users were sent to different kinds of shops. Like if you want to have a festival ticket, you go to the regular shop. If you want to have access to the camping grounds, then you need to go to a different shop. If you want to have bus travel, go to a third party. If you want to buy merchandise, then you need to go to the merchandise shop. And that is something that Qdance wanted to change. So with the one-stop shop, we have a shop which has all the products at once, so you can buy them in one go. And the products we have available are entrance tickets to the festivals, of course. Also accommodations, so that could be a hotel or a camping spot. Bus travel, merchandise, so that's caps and T-shirts and whatnot. Also parking, lockers, and you can also insure your visit to the event. So of course there are a couple of main challenges here. It means that we need to deal with different vendors. So from a user perspective, there's just one shop, but behind the scenes there's many different vendors, because every of the things you just saw have a different vendor. So that means that we need to have a shop that can, under the hood, talk to different vendors while the end user doesn't know this. So also you can imagine that if there's an event coming and people want to buy the tickets, there's a moment we call peak sale. So that means that all the users are like gathering in front of the doors of the shop, and they want to all buy tickets because they don't want to miss out on their favorite festival. So that means that we need to be able to do this all in high performance mode. And there the complexity is that we cannot keep calling every vendor in real time to know about their stock. So that means that we need to import the stock from the vendors and manage the stock ourselves in real time. And for the user, it means, as I mentioned, a single payment. So the user only needs to pay once, but in the background, we need to make sure that all the different vendors are paid. And then it got interesting. Our client, Qdance, they requested They don't want to have running servers. So that means that we needed to go serverless, which happens to be one of the things I'm most excited about. So that was a lot of fun. But I'm not sure if everyone knows what serverless is, what it means. Of course, it doesn't mean that there's no servers involved, because the code needs to run somewhere. So that's why I put serverless in quotes. It's a bit of a misnomer. But in general, it means that there's no provisioning. So you don't need to set up any servers, configure any servers. It involves autoscaling. So if there's more load, then it will autoscale. If there's no load, you basically pay nothing. So that's also where the pay-per-use comes from. So if you're not using it, you're not paying for it. Also, it's fault tolerant. So there's like implicit retries and that such. It's all integrated. So that's a really cool thing, and it makes managing stacks a lot easier in a lot of use cases. Not all of them, but it's really cool technology. For this project, it means that we've used cloud-based managed services. So that means like databases and file storage. Also, we're using functions as a service. So instead of like with Drupal, you have a framework, and every route is coming in that framework, and all your source code of your entire app is in that code base. With functions as a service, you write one small function, and that's the only function that gets executed. So that's quite a big difference. Also, it's not running on a server that you provision. It's just it gets spawned or executed when it's requested. We've also got a decoupled front end, and our client is using a headless CMS called Contentful, which is it could have been Drupal, but they chose something else. And also the entire stack is event driven. So I think this is the most interesting part, the architecture. I want to really deep dive into how we did everything. So hopefully that will give you a lot of ideas on how you can use this cool technology and create something yourself with it. So the components that we have is the yellow part in the top left is the front end, which we didn't build, but it's of course still part of the shop. All the rest of the items we did build. So there's an API that the front end is communicating to. The API is communicating with databases and file storage. We have the red box, the order handler. This is the most doing all the heavy lifting. I will show you this in a bit. We of course have a small admin tool for the shop itself. And then we have on the left side stock sync and cart cleanup. We have some background processes which we need to have for the shop. So our entire stack is running on AWS. I'm not sure if many of you have worked with it, but they offer many different services, and we've used quite a lot of them to make this all happen. And I will show you, of course, for every part how we build it and what kind of services we're using. By the way, if you have questions, feel free to ask them. I will answer them after the session. So the front end, the front end was built with Vue.js, and as I mentioned, we're using Contentful CMS to make sure that all the copy and all the imagery in the front end is being like event specific, and everything is then statically generated, and it's put into an S3 bucket. So all the files are being uploaded in the S3 bucket, and we have a CDN, content delivery network, in front of that, so we can have fast response times from all over the world, and that gets like requested directly from the browser. The API is of course more interesting. The API is responsibility is working with products, so it can retrieve what products are available, what kind of stock is available for those products. You can create your own cart. And eventually, if you put products in your cart, you can turn the cart into an order. Also, there's some business rules in place. We created a business rule engine for this, which allows Qdance basically to set up different moments of the shop. Like for instance, when they have a big festival, the first week where you can buy tickets, you are required to also purchase a accommodation with your tickets, and the amount of accommodation people in the accommodation must match the amount of tickets that you buy. So there's all sorts of business rules in place, and the business rule engine verifies that when you want to convert your cart into an order, it will deny that if the business criteria aren't met, and it will also explicitly explain you why the order is not allowed to be placed. So for the API and all the coding, we are using Serverless framework, the open source version. Not sure if anyone used it, but it's a very cool framework, and it's not a framework as maybe Drupal as a CMS or Symfony as a framework. This is more like a framework that allows you to like manage your code, and the serverless framework will be able to package it and deploy it to your environment. So all the configuration is done with YAML, and it's basically a command line tool, and it supports multiple hosting providers. So we are using it mainly with AWS, but you can also use it with Google Cloud and IBM and Azure, of course. But there's a lot more. Also, it supports multiple languages, so you can use it with Python or Node. PHP, not officially, but if you really want to use PHP in serverless framework, that is actually possible. You can use Bref, bref.sh. And as a proof of concept, a while ago, I tried to run Drupal on Lambda, and using Bref, that actually worked. So that's pretty exciting. And also, the serverless framework, it allows you to run apps locally. So you can test your apps locally if you want to. So that's also really interesting, very helpful. So the API, again, the browser is only communicating to CloudFront, which is the CDN. And then CloudFront is connecting to API Gateway. And with API Gateway, you can define your routes, and you can point the route to a specific Lambda function. And that Lambda function, that will execute the piece of code that we uploaded, and that will basically pull data from Redis. And it will write its orders to an S3 bucket as a JSON file. And as I mentioned, we have peak sale mode. So when you can see on the screenshot, there was at that moment for a festival, there were 32,000 people in a queue waiting to buy tickets. And of course, we need to deal with that amount of users. So luckily, our payment provider offers a queue that can like manage this amount of traffic. And what happens if a user goes to, they receive the URL to the queue, and basically the queue keeps track of how where you are in the queue, and we can configure how many people per second are allowed to go from the queue to the actual front end. And if someone would try to go to the front end immediately, they will fail, because the queue will send along a token as a query string parameter. And while we create the cart and peak sale mode is activated, we verify with the queue API that the token is actually valid. So if someone tries to bypass the queue, they will just be detected and be sent back to the queue. So that also means that there's no way to bypass or cheat or any way, because even opening multiple tabs, it can only result in you waiting even longer. Then there's the process called the order handler, and I think this is the most exciting bit. Basically, the only thing it does is sending emails and informing vendors, which sounds pretty easy, but actually it's a lot more complicated, because the vendors all need to be informed about what the user ordered. But it must be done in a way that after everything is done, then the user will receive an end email. So that was a bit of a tricky part to figure out, but because it involved like tying functions together, like you have multiple functions and you need to have like a way of tying them together and knowing which function is at which, which function actually already proceeded and which is still waiting. Luckily, they at AWS have got a beautiful system for this, and it's called Step Functions, and it allows you to tie functions together. So in this example, it shows that a user might upload a photo to a bucket, and when that photo is uploaded, it will actually detect what's on the picture. So in this case, mountains, people, and snow, and it will also create a thumbnail. If you look on the right side, it's a state machine that gets started basically when the image is uploaded. So it will extract the metadata. It will check if it's a supported type. So if it's a bitmap, it might not be supported and it fails. If it's a JPEG, it will pass and it will go to the next function. And there in parallel, it will run recognition, which is the service that can turn the image into mountains, people, and snow. And it will create a thumbnail. So that's a way how you can tie functions together as a state machine. So that's extremely powerful. And that's also what we are using for the order handler. So as you can see, it starts by sending a confirmation email to the user. It will send an email right away to the user, like, thank you for your order, we're going to process everything. Then in parallel, as you can see, there could be multiple here. If a user bought tickets and bus travel and also merchandise, there's 3 vendors we need to inform. And then we'll do that in parallel and put that in a queue. Then after that parallel work is done, we will send a details email to the user, like, thank you for your order. We've processed everything. You have ordered these tickets. This is your order ID at the ticket vendor. If you have any issues, please call them. You've also ordered a t-shirt. So here's your receipt and your order number for the merchandise and so forth. So that gives the user also the idea that it's actually one shop where they purchase their products. And when it's done, we basically move the order from an unprocessed folder into a processed folder. I see questions incoming, but I will answer them later, I promise. So the parallel bit is, of course, quite complex because we send something to a queue, like what needs to be informed, telling the vendor, like, okay, this user purchased a t-shirt. We put that in a queue. And why do we do this? We do this so we don't overload our vendors. Some of the vendors explicitly stated at the beginning of the project, like, okay, sorry, we cannot handle the amount of load that you can, so make sure you don't overload our servers. And what we basically did is we put it in a queue, and we have one Lambda, which is executing the logic to inform the vendor. So it basically calls our API. And we just set the Lambda max execution to 1. So we only have one Lambda running at the same time, so that we can guarantee that there's like a steady pace of informs to a vendor, and we're not overloading their system. So we inform the vendor, and when we detect that it's basically it's a 200 OK, then we signal this back to the main order handler, and we also write logs to S3. So what we do there is we write success and error logs, so in case anything goes wrong, that we are able to figure out what happened. And if all of these tasks are done, all the vendors are being processed, then it will jump to the next step, which is sending the details email. And the beauty is that that managing this state is all done by us through step functions. So we don't have a database where we are keeping track of where every order is. That's all managed. So how do we trigger the order handler? As I mentioned before, the API is writing an order JSON file to an S3 bucket. So that also makes sure that we can never lose our orders. And whenever that order is placed, it's written to a bucket, and that write will trigger a Lambda function, and that will execute the step function. So unfortunately, there's no way directly from a trigger, or there's no trigger yet from S3 directly to step function, so we needed to do that manually in code. Also in the shop, we have a couple of background tasks. We have stock updates because, of course, tickets can and other products can be sold out at some point, which of course is good news for QDance. But the end user must also be aware of this. So we made a process of stock updates, which allows us to broadcast in real time updates from our backend to the end user. So we can show them like an alert, like, be careful, there's only 100 tickets left. So if you want to go, then please make sure to put it in your cart. Because if you put something in your cart, we keep it for you reserved until you either wait too long and your cart gets cleaned up, or you convert it into an order. So if you have a ticket in your cart, it's actually yours. So it cannot happen that you put something in your cart and you go to order and it tells you it's sold out. That is something that we didn't want to happen. Because I think everyone is really bummed out if you put something in your cart to figure out a few minutes later, like, oh, it's already sold out. That's just really annoying. So we want to make sure that all our users are aware that once you put it in your cart, it's yours if you actually pay for it, but it's yours. It's reserved. It also means that if a user is waiting way too long, or they are just closing their browser, we have that cart somewhere which is still reserving those products. So that means that in the background, we need to remove those carts and make sure that the reserved products are putting back into stock. So that's something that all happens in the background. Also, we have some dashboard statistics because it's, of course, nice for the business to see how fast tickets are being sold. But that means that what I want to do is those background tasks. It depends a bit on the time of the shop. So, like in peak sale mode, you want to have these updates done maybe every second instead of hours. Or like if it's outside of peak sale, then we won't sell as much as we do in peak sale. So then it's less interesting. But what I wanted to do is create some kind of mechanism where I could say, like, okay, run this process every second. And basically, I'm describing a cron. And luckily, in CloudWatch, which is a service that can trigger a Lambda, you can set up crons, which is beautiful, but they can only go as low as once per minute, which for us wasn't good enough. So I was thinking about the step functions again. Like, is there something I can do with that? And with CloudWatch, we are now regularly calling a Lambda, like once per hour. And that Lambda is triggering a step function. And that step function is something that I call the mechanism dynamic cron. I know it's a really lame name, but I couldn't find a better term, and I think it covers what it does. What it does is I pass an interval to the step function. So that interval could be the amount of seconds that I want to run my function. And that interval could be as low as once per second. So I pass 1 second or one as the interval, and then it will first try to find out using the step functions API. It will try to find out if there's already a running cron. If that's the case, it will kill the other cron. So then this is the only one that stays up. Then it will execute the part that I wanted to do. So this could be cart cleanup or stock updates or something like that. Then it will keep a counter. It will keep a loop counter, and it will keep track of how often that was executed. So I will evaluate the amount of count of the loops that ran, and if it's below a certain amount, let's say 1,000, then it will wait for the amount that I defined in the interval, and then it will run the function again. So this process can run a couple of thousands of times, and then eventually there's a limit to the amount of steps you can have in a step function. So I need to break out of that. And what it simply does, it's when it breaks out, it will trigger itself and with the same interval, and then it will end the current instance. And that way I have a continuous loop of my dynamic cron. And the really nice thing is we also have a dashboard which allows us to change the interval. So if I start the interval with a new interval, like maybe once per hour, so 3600 seconds, it will kill the instance which is running at once per second. And then I can immediately change the speed of my dynamic cron. I hope that all made sense. So for the real-time updates to be broadcasted to the user, we needed to have some kind of WebSocket connection. And while Lambda nowadays does support WebSocket connections, or API Gateway does it, I must say, we didn't see that as an ideal solution. And we've come up with a more cost-effective solution. And basically that involves a service called IoT Core. And IoT Core, it allows you to set up a WebSocket connection with Amazon servers using the MQTT protocol, which is also used for home automation and such. So some of you might know what that is. Basically, it means you can send JSON messages over a topic. So it's pretty flexible there. The only thing you need to do is to be able to connect to IoT Core, you need to have permission to connect to it. So what we do is we generate a pre-signed URL. So the user fetches an API endpoint, and it will just return the URL that the client can listen on. So it can connect to IoT Core. And basically, we only need to have a read-only permission because we only receive content. We don't allow the user to send any content. So there on this side, you see on the right side, you see the step function. That might be the dynamic cron that I just showed. And it's executing a Lambda that is fetching the current stock from the Redis database. And it will then broadcast these stocks to IoT Core, which will send it to all the connected clients. And we can do this even as low as once per second. So that's extremely awesome, I think, to have all of this in a serverless environment. There's no running server that we need to manage to make this work. We also have a small admin tool, as I explained, and it allows you to manage events. So you can create your new events, attach product to events, set up those business rules. It allows you to view the incoming orders. And also we do some basic monitoring to see if there's any order failures, for instance. The admin tool also, again, is running behind API Gateway. It's all API based, and it's connecting to Redis and the S3 bucket to fetch maybe the order, and also to DynamoDB. We are also storing certain things in DynamoDB. By the way, we're using Redis as a persistent data storage. So we're not using it as a cache. We're actually using this as a persistent data store. And this is really, really cool. We've been doing it for years. And it's also, it could be dangerous, of course, using a memory cache to serve as your primary database. However, you can configure it in AWS to have failovers, and you can have a replication. So actually, it's a really safe thing if you set it up right. Then I think I have two more things that I want to show you, which show the flexibility of this setup, because we're using event-driven architecture. And we're using this for monitoring and alerting, because we have that step function, that order handler that's running, but you can also listen to status updates on the step function. And that gave us the idea, like, okay, we can just set up a rule which allows us to trigger a Lambda when a new order handler is started or ended or failed. So we get a trigger every time something happens with an order handler. So that allows us to take the information from the step function, so we know which order it is about, and we store it into DynamoDB. And whenever the step function, the order handler, successfully completes, we also update it into DynamoDB. So we can count easily how many orders there are successful, or maybe that have an error. Also, if there is an error, we can just send out an email. So we know that, okay, this order is broken. Someone needs to pay some special attention to this one and figure out what happened. So this was really easy to add, and it's not even part of the original code base of the shop. It's just something extra rebuilt against the existing shop, and it doesn't touch each other because everything works by events. Something else we were able to do with this, as you might understand, Qdance is heavily hit by the COVID situation. So while I can just do my coding from home, they cannot give their events, which is of course really painful to their organization. However, they are also looking into alternatives. So they already did a couple of live events online. They've done DEF CON at home, which is DEF CON 1 is their biggest event of the year. And they basically they wanted to thank all their fans for their loyalty for keeping their tickets until next year. And they created this awesome DEF CON at home event where they had 3 days of live streams with an actual stage on the actual site where they usually do the event. And it was a massive event. And they also recently did an event called Climax, and they created a movie for that. And what they want to, they basically sold tickets to watch the movie on the live stream. So users were purchasing a ticket to watch the live stream. But then, of course, when a user is going to watch the live stream, you need to verify that they actually bought that product. And this setup that we have allowed us to do that because we are storing the information of the order whenever it comes in. We basically are storing what a user bought in a DynamoDB table. And whenever the user wants to watch the live stream, there's a server-to-server call checking our API, like, hey, did that user actually purchase this product? And this allows us, like within a second after a user has done their purchase, it will put in the DynamoDB table that the user actually purchased it. So it's like a sub-second interaction within the ecosystem that we know that someone purchased it. So that was really awesome and very helpful in this situation where they wanted to do live streaming, like paid live streaming. So that's really exciting. Of course, everything didn't go as smooth as I'm telling you now. As if you didn't know, validation is hard. So it's even more harder if you working with different vendors. So if you have 5 or 6 vendors that you're working with, all of them have their own validation, and everyone wants to receive the zip code of the user in a different format or their date of birth in a different format. That's hard to figure out. Also, it happens that vendors change their configuration. They might change their API, or someone within the business decides to, this actually happened, to make the user's region a required value, which we didn't use in our shop. We didn't ask the users for their region. So that suddenly broke all the orders involving merchandise. So that's very interesting to figure out, like, okay, what happened? And you start calling the vendor together with the client, like, oh, someone in your own organization switched on this as a required value. So that can happen. Also, the business can change stock without us knowing it. We manage the stock, and we assume that if we manage stock, the stock is exclusively for us. Since we don't ask the vendor if there's any stock changes. We import it. If there's 1,000 t-shirts, we are assuming, and we must assume, that those 1,000 t-shirts are available, because when someone purchases it, we put it in their cart, they pay for it, and for all they know, it's theirs. So what happened once is that there was a sale going on, and also the same day there was an actual event, and someone decided, like, oh, I got a couple of 100 t-shirts lying around, I'll just bring them to the event. And they took it out of the stock in the merchandise system, but we weren't aware. So everyone buying that t-shirt had a broken order. Also, the dynamic cron stopped at some point, which was doing the cart cleanup. So suddenly the event was listed as sold out while it wasn't. So when we started it up again, it turned out that there were still a lot of tickets available. Also, the brands within the ID&T group have different needs. So it means that while Qdance has their own supplier for merchandise, it might mean that someone else in the ID&T group has a different supplier, different vendor. And sometimes it could be a bit of a black box. If you want to debug this, you need to, of course, have quite deep knowledge on how the product actually works to figure out what's happening. So that could be difficult sometimes. So for the future, we want to focus more on getting order details from the admin system, and also getting the actual user information in there, which we currently do not show to the admins. Also, we're working on a wish list feature where you can, like, in advance, get access to the shop, create your entire wish list, and when the store gets opened, there's no need for you to browse through everything. You can just open your wish list and go to the order, convert it into an order immediately. Machine learning personalization is something that we want to look at. Since we know which products you're buying and which events you're going to, it could be really nice if we know that the user always buys VIP tickets. It could be really interesting to put that on the top of the site instead of showing the regular tickets first. Also, we want to add more brands within the IDT group. The goal is, of course, for all their brands to use it, this shop. And that also leads to adding more vendors. So I think the key takeaways of this session is that give serverless a try. It's really awesome, and it allows you to quickly build and try new things and be really flexible. And if it doesn't work out, it's not bad because you're not paying any money for any running servers. Also, event-driven architecture is really exciting because, as I showed you, you can just put things on top or next to your current stack to do things that the original product wasn't doing, and it allows you to manage that separately. So it's really powerful. Also, I think looking at Drupal a bit, using a headless CMS for your content is really great. I mentioned that this client is using Contentful, but it easily could have been Drupal doing this. Like, you can manage all your content, build a static site with that information. I haven't used it myself, but I think Gatsby is a really great tool to combine your front end with something like the Drupal CMS. And also, it's really okay to use different databases. As I've showed, we are using Redis as our primary database for the shop itself, but for keeping track of who ordered what, we're using DynamoDB, and also we also have some analytics, like all the order information is also put into a Postgres database for the analytics team. So that's all okay. Don't try to squeeze things in databases they aren't built for. If you would want to add a search, add Elasticsearch, and don't go messing around doing that with DynamoDB because it's not suitable to do that. Okay, with that, I want to thank you a lot for your attention. I see quite some questions. I'm not sure. I have a couple of minutes left, I believe, so I can try to answer a few of them. Local development. Yes, you can do some kind of local development here, but with using all the different services together, that is really tough. So we actually have just a dev environment where we are actually uploading or deploying this to, and from there we're doing testing. Just like with your own code, also in Drupal, if you are doing your functions, you can, of course, as best practice, do unit testing, so that you at least know that your individual units are all correct. And from that moment on, you can be sure that your functions on their own are working. And then looking at the whole chain of events, I think it's easiest to do that in a real setup. That's outside simple unit testing. Yes, I think I kind of covered that. I see more questions incoming. The project isn't the project Tomorrowland. No, Tomorrowland is a party from a different organizer, but they are friends though. But they are not using this shop. Question from Florian: what guides did you use to get AWS in the deep? Many may think AWS is like a huge can, do all black box, and they don't know where to start. Yes, that's a very good question. I think you need to have a lot of passion and just have some kind of small things to start with. Of course, AWS offers many different things. It's a really good question. I'm not sure how to answer this. Personally, I'm just driven by always going forward and exploring new things. So if I see something new that is being done on the AWS news page, and if I'm interested in the service, then I just give it a try. And while this project was incoming, I never worked with step functions, but I remember that I read something about a serverless state machine. So I was thinking like, okay, maybe this is a good fit for this project. And then I just create a proof of concept, and it worked. Oh boy, there's a lot more questions. Please elaborate any reasons why content type was actually contentful was used and not Drupal. They are basically, they were already using contentful for all of their other websites, so they are comfortable with that, and there was no need for introducing a new system to that. Of course, we're also doing Drupal as an agency, so we have nothing against Drupal. We recommend it a lot of times actually, but for this project, we simply didn't need another CMS as the client already had one. Was the write to S3 done? Question from Ajit. Was the write to S3 done for performance as opposed to writing to a database, or was the decision part of going serverless? Very good question. I think writing to S3 is just easy because it has a 99.999% guarantee of availability. And from that moment on, whenever something is written to S3, you can trigger something. So if you want to write it to 5 different databases, you have just 5 lambdas that are actually going to write to those databases. So writing it to S3 for us is just adding flexibility to the system. And also in this case, it easily allowed us to trigger that order handler. Let's see, if headless CMS are the future, the current front-end capabilities of the CMS will become irrelevant in the near future. I don't know actually. We are, as a company, we are using headless CMS a lot, but still you do see a lot of great projects which actually do use their front end. Also things like live editing and such that I think is really powerful. Also a really powerful feature of Drupal. So I don't see it going away, but yeah, I think it depends a lot on the project. I don't think there's a wrong or right there. I see my session is ending in 1.5 minutes. I see some stuff in the chat. I'm not sure if those are questions. Studying for AWS certification, solution architect. Yes, that's definitely a good choice. I didn't do it myself, so I can't tell you if it's good, but from what I've heard, it's a really good way to learn about the different services that they offer. Also, something to add, if you sign up for AWS, you do need to have a credit card, but they do have a very generous free tier. So in your first year, that's even better. It's even more generous, but after that, you can have like 1 million Lambda invocations per month. So you can do a lot of testing on the actual AWS services without it needing to cost any money. So that's very interesting to get started with. Okay, I think that's it. If there's any more questions, feel free to reach out to robert@mediamonks.com. And I hope you had a good session. Enjoy DrupalCon. I'm sure I will. And thanks to all the sponsors. Thank you very much for your attention again. I'll see you next time.